Alright, hold on to your hats because this next lecture is going to be a little bit tricky for some people to understand. What we're going to talk about this time is the one-shot, ONS. We're also going to look at the OSR, one-shot rising, and the OSF, one-shot falling. Now, so far we've been looking at bits, and it's been real simple. We energize the bit, we de-energize the bit. We check to see if the bit is energized, we check to see if the bit is de-energized. That is the basic element of PLC programming, particularly in terms of digital programming. But now we're going to get into a little bit more complicated instruction. Imagine for a second you're operating a push button, and you push the button one time. Well, when you push that button, for how long is that button depressed? Now, even if you press it fairly quickly, you imagine that button is still pressed for at least a tenth or a fifth of a second. Remember, our PLC can scan maybe once every 6 milliseconds. So if we're scanning that fast, when you push a button one time, how many times does the PLC scan? Well, theoretically, that can scan 20 times just while you very quickly push a push button. So if you want the PLC to do something one time instantaneously, to check a reading, to record a value, and you only want it to happen exactly one time when you push a button, how would you program that? Because when you push that button, the PLC is going to scan 10, 15, 20 times, and it's going to do that action that you only wanted to happen once several times over. And the answer is this instruction right here. It's called a one-shot. Now, right now, I'm introducing all of these instructions, and I know it's a little frustrating that you don't get to see them in action, and especially some of these things that happen instantaneously, it's a little hard to watch them. But we are going to actually see these things working on an emulator later on in the series, so bear with me. Right now, I'm introducing these instructions, I'm explaining them, giving you some best practices. You'll forget some of this stuff, but we're going to go through it 2 more times throughout this course, and by the end of it you'll have a firm grasp of the concept. So right now, try to take it in, try to understand it, and don't worry, we are going to come back to it and get a little deeper into it. But for now, this is how the ONS, which means one shot, this is how it works. When the light switch gets flipped, whenever this block transitions from false to true, then the one shot changes to true for exactly one scan and one scan only. So whatever action is over here will happen one time during one scan, and then after that one scan, this one shot becomes false, and it remains false until this light switch becomes false and transitions back to true. So basically, when you have a one shot, everything to the left of it has to become true. And for every time it becomes true, the one shot will become true. Once it becomes false again, then the one shot will reset itself. And once everything becomes true, then it'll fire again and become true again for only one scan. So the way this line right here, we're just looking at rung 0, pretending that there is no rung 1, rung 2, rung 3. Just rung 0. The way this would work right now is if I walk over to the wall and I turn the light switch on, this one shot will become true for one scan, and my light bulb will light up for 6 milliseconds, which means I won't even see it light up. It won't even light up enough to produce light visible to the naked eye. And then this becomes false, so this remains de-energized. I turn the light switch off, nothing happens. And when I turn it back on again, mind you, I'm transitioning again from false to true, then my light bulb will come back on for an additional 6 milliseconds. Now, when you need something to happen only one time instantaneously, the one-shot instruction will do what you need, and you can use that 95% of the time in such situations, and it'll get the job done. But there are 2 other instructions that have a little bit more functionality, and they are available, albeit not in all programming environments. One-shots, you have those pretty much everywhere. When you get into some other processors and some other manufacturers, they won't have these 2. But just in case you do end up programming with RSLogix 500, or if you're using a system that has these, I'm going to go ahead and introduce them. They're a little bit more functional, but it does add a little bit of complexity to your program that just does not have to be there. So let's look first at the one-shot rising. Again, we flip our light switch from open to closed. So this block is transitioning from false to true. When that happens, you see this one-shot rising. Now, unlike the one-shot you see it on the left of the rung because it acts as a condition. It becomes true or it becomes false. The one-shot rising and the one-shot falling, on the other hand, you see them to the right of the rung. That means they're outputs. They're not conditions. These are actually energizing and de-energizing bits. So what happens with B305 and B306? When we flip this switch from open to closed and this becomes true, then we have our output bit, which works exactly like the one-shot. For one scan, it becomes true, and then it remains false until the next time this light bulb comes on. And actually, instead of the light bulb, let's go ahead and look at the light switch. That's better. Now, the B305 bit works differently. It stays on with the light switch until it's turned off. Just like the one-shot rising, we have the one-shot falling, which works on opposite condition as the one-shot rising. So again, we're going to sub that out with our light switch. The one-shot falling doesn't fire when the light switch transitions from false to true, when it transitions from open to closed, but vice versa. When we turn the light switch off, when this condition becomes false, then we instantaneously fire our B304 bit, which lasts for one scan, and then de-energizes again, and our storage bit fires and stays energized until the light switch is closed again, in which case both of these become de-energized. So you have an extra sustained bit on your rising and falling. One works on a false to true transition, one works on a true to false transition. But the one shot which is much simpler, only involves one bit, and will give you the same one scan functionality as these two, will handle 90 to 95% of your needs. So when possible, stick with the one shot. If you absolutely have to have both bits, there's certainly nothing wrong with using one shot rising or one shot falling. I'm a fan of keeping it simple. There is one caveat that I'll add to the one shot, and that is that depending on the processor you're using, some processors don't allow you to have multiple instructions to the right of a one shot, and some processors don't allow you to branch around a one shot. So when you're programming with one shots, it's oftentimes simplest if you have one shot on each branch with one output, and on the next branch one shot and one output or one action. The last thing that I'll mention is, you see we're using an address here, B301, for our one shot. Again, you want to use one address per one shot, and you don't want to use that address for anything other than that one shot. So if you have 4 or 5 or 10 or 50 different one shots throughout your program, every one of them needs its own address. You can always refer to a one shot, but what you don't ever want to do is energize the same bit in 2 or 3 or 4 different places. Not only is it complicated, but it'll also add some very unpredictable and usually quite undesirable operation to your program. It's going to put a bunch of bugs in there, and people are going to think you don't know how to write a program. So energize a bit one place and one place only. Every one shot gets its own bit. If you're using a one shot rising or a one shot falling, they get 2 bits, and nothing else uses those bits. You can refer to them, you can check to see if they're open, you can check to see if they're closed as conditions for other logic. But what you don't ever want to do is energize either one of those anywhere else, i.e. use either one of those in another one shot, a riser, a faller, or anything like that.